Hello and welcome back to openheatloss.com and another instruction video on how to use the tool and how to create a wonderful heat loss calculation and system design for yourself, particularly for a heat pump. Now, we've done our videos up until now to cover the rooms and the heat loss summary. So we know now what we're actually looking to achieve in the house. So if we go back to the heat loss summary of the example project that I've just put together, we have set up a heat pump specification, and we know now that that works well for our 5.2 kilowatt generator sizing load, and that we also know that from a kind of a defrost perspective, we've got 135% on the sizing margin, so actually we're all right. And we also know that we've got a good enough modulation at 2.2 kilowatts to deal with the 2.8 kilowatts typical load at reference temperature. So we're doing all right. And now what we need to do is we need to tackle the total emitter sizing. Now, as I've discussed before, you'll notice that the emitter sizing is greater than the generator sizing, and that is because there's been an update in the methods used in the UK for sizing heat pumps and heat emitters. And what this does is that the calculation takes into consideration air infiltration, cold air infiltration into the building from one side versus the other, because if you think that you've got a strong wind blowing in the middle of winter, it's going to be pushing cold air in on one side of the house, and the radiators in that house, in those rooms, need to have a greater output in order to deal with that greater influx of cold air. So I will do a full video at some point really explaining how all of this works, but for now I think just be aware that it is absolutely correct that emitter sizing is greater than generating sizing because of infiltration, particularly in older houses that have not been built to high air tightness standards and insulation levels. So what we're now going to do is we're going to go over across to our emitter sizing. Now, the first thing you're going to be struck by when you do your emitter sizing is your system design conditions. Now, normally on a default basis, you'll get a flow temperature of 50, return temperature of 45, and a flow and return, obviously, delta T of 5. Now, I personally prefer, whenever I'm doing a radiator system, and that is what we're going to concentrate on today, is just dealing with radiators. We're not going to deal with underfloor heating. What we'll do, and what I will do, is I will do a video later on where I talk through how to size according to the underfloor heating and so on, because it is more complex than the radiators. Okay, so that'll be dealt with in another video, and in that video I will also deal with systems that have a combined underfloor heating and radiator system too, and how the system deals with that and can help you with the appropriate design on that basis. So what I'm going to do then is I'm just going to put my system design conditions at my preference. So for a radiator system, I prefer to go in at a 45 degree flow temperature and a 40 degree return temperature. Now, check the heat pump specifications, because there are actually some heat pumps out there that like to have a 7 degree delta T, and there are some that it'll be specified that as preferable in the installation manuals and the commissioning manuals for those systems. So just bear that in mind. But normally the assumption is 5 degrees delta T, and for a relatively efficient radiator system, 45 degree is all right. But I have to say, if I can, I will very much try to get it down to 40 degrees centigrade, because then usually you have a really nicely efficient heating system on your radiators. But start with 45, and then those design temperatures can be played around with anyway. So don't worry about it for now. Just go with this, put it in there, and then we'll take you through how to play around with it later. So the next thing is your system emitter summary. So here it's just giving total emitter sizing load 7.05 kilowatts for this example project, and at the moment we've got 0 scheduled output. And it's just giving a warning that action is needed because there is a shortfall. Well, yeah, quite a big one there. So we then move on to the room by room design aspect. So if I open up the first room, what you're going to see here is that based upon our flow and return temperature of 45 and 40, it is calculated. So what it does is it's obviously got our heat loss calculation from the room. It then has a mean water to air temperature difference. So that is the mean water temperature is basically your flow and return added together divided by 2 minus the design room temperature. So here the room temperature has been designed at 21 degrees centigrade. And from that, because radiators do not have a linear output, so here we have this one has calculated the output at an exponential of 1.3. The system uses a conversion factor. And now what does that mean? So to explain that, we're going to go across to this area here where it says the required output at delta T50. Now delta T50 is the standard by which every single radiator on the market is still tested. Okay, now that standard is based upon a mean water temperature of 70 degrees centigrade and a room temperature of 20 degrees centigrade, and that calculates the measure of the output at under those conditions. Okay, so what I'm going to do here is I'm going to just show you an example of how that works. Okay, so I'm going to take this up to 80 and then I'm going to take that to 60. So we got a flow and return delta T of 20, flow temperature of 80, return temperature of 60. And then I'm just going to nip back to the room here on our ensuite, and I'm going to change this to 20. Okay, and then we're going to go back to the sizing and open that up, and there you're going to see now that because of this we have got a mean water temperature design of 50. So our heat loss is 485. We've got a connection type which is consistent with the test as well, so it gives it a radiator output of 1, and there we go, we have a conversion factor of 1, which means that the delta T output of the radiator we select is 485 watts. So that gives you an idea of where that test mechanism comes from. Okay, so what then happens is if you reduce the flow temperature like we're doing to 45 to 40, and then I'll go back and change the room temperature as well because we're going to put that at 21. What happens then is that the difference between the water temperature and the surrounding air is lower. And if you think about the way heat moves, is that the greater the difference between the hot element and the cold element, the greater the transfer of heat. The closer they are together, the less there is a transfer of heat. And so what that means is that this conversion factor takes that into account by saying, well, okay, if there is only this difference between the temperature of the water in the radiator and the temperature in the air, then I can only, the radiator can only give out a certain amount less heat. That's what it's doing here. And so what now it's doing is it's saying that with this mean water air temperature difference, the radiator we are going to choose has to put out approximately 3 times as much heat, or be able to, at the industry standard test measures. Okay, this is why people talk about how heat pumps have to have bigger radiators. Now, they don't have to have bigger radiators, they just have to have the right size radiator. And in some houses, small radiators are fitted. In other houses, big radiators are fitted. So, you know, we have to figure out how much output certain radiators or fitted radiators can how much heat they can give under the circumstances and the conditions for an efficient heat pump installation. Okay, I hope that makes sense. Now, on this instance, what I'm going to do is I know that the radiators in this room are actually fitted as bottom opposite ends. So this is where the valves are at the bottom of the radiator on each side. Now, this test is done with top and bottom same end. So you'd have a valve at the top and a valve at the bottom on the same side of the radiator. And to get extra output of 1.05, you would plumb in your valves onto the radiator as the top on one side, the bottom on the opposite side, and then you get a really good, a much better output. But on the radiators in this house, I already know that we're bottom opposite ends. So I'm going to click that button there, and you're going to see that that's actually changed now, this output, because we now have an additional conversion factor of 0.96 based on this connection type that is also used in the calculation. So if I go back to the top and bottom same ends, my output required is 1511. If I go to bottom opposite ends, it's 1574. If I go to top and bottom opposite ends, it goes down to 1439. See, so changes the output required depending on how you connect your valves and the flow of water into your radiators. All right. Now, because this is a retrofit, I've got some existing radiators. So it has told me that I have an existing radiator, and it's asking me if I'd like to import that. So I'm going to do that. I'm going to import that radiator. And what it's now going to do, so it's shown me the type of radiator, and I also here have options that to modify and calculate modified values of output. There are different enclosure types. I don't have that worry. I don't have it with an encased thing with ventilated grill. I don't have any shelves over it. It is just on a plain surface, so that's okay. Then I just know that I've just got the standard paint, so that's okay. But if it had been painted with metallic paint, for example, then it would have a reduced output in comparison to its factory output. Okay, so this one now is giving me a slightly low output here. So what you can see here is just telling me here at the bottom that I've got an insufficient output, and it's going to be telling us some different figures on here. And it might get confusing with the percentages that are going on. But what I'm going to do is try to explain this. Now, what it's doing here is it's telling me that this radiator is only providing me with 53.9% of the target output. And the target output equivalent is 1574. So you can see there is my 849. Okay, now down here it's then doing a calculation, and it's telling me that I'm 46.1% short on my total output. Okay, so that shows you those kind of percentages. So if I add another radiator here, I'm just going to show you. So obviously this goes in as new. Now let's just find a really small radiator. So the way this works here for a radiator selection is I just put in the dimensions I want, and it comes up with a radiator that is close to this measurement and gives a suggestion. And what it then does here is you can see that it has my 302 watts at delta T 50, and it's giving me 101 watts at the design temperature. So you get an example. It does a calculation to show you how close that is to your design. So I'm just going to select this one. I know it's not enough, but I'm going to select this one. And so what we can see here is that the output here is 302 watts at delta T50, and it's 101 watts at the design output. Now what you can see here is that then this is, there says 19.2%. So that only gives out 19.2% of the total value, okay, of what of the full output required, okay. And then you can see here we're at 26.9% less than we need to be compared to the target delta T50. Now this is where it gets slightly confusing when people look at this, is because we've got 26.9% low versus target on the delta T50 figure, and then we've got 504 watts, which is minus 23.8% on the actual target design output. So I don't want to be don't want to make this too confusing, but basically because the output is non-linear, you get different percentages on those. Okay, hope that clarifies it. But what we can obviously see is that we're still at insufficient output. Okay, now I'm just going to go back. I'm going to delete this radiator, having hopefully not confused you too much about these percentage figures. And what I'm going to do here is I'm actually just going to say, do you know what, I'm going to replace this completely. I'm going to get rid of that. And then what I'm going to do now is I'm just going to add a new radiator, and I'm going to see if I can add a 600 by 600 radiator instead, and get away with the right output. So as you can see here, I've got several that are listed at this kind of output. And I'm going to go through here and see whether there's any chance I can get a 600 by 600 in there that actually gives me what I want. And I can see that actually it doesn't, because whichever way I go, I'm a little bit low. So if I go to a K3, it's 1508 watts. And what I really ideally need there for my temperature is 1574. So I'm not going to be able to do it. So what I'm going to do here then instead is I'm just going to select from a list. So I'm now going to go through this list and find something that might just work. And if I go to, you can see down here, I've got an output there of 1651. That could work. I think that might be the way to go, as a 600 by 900 for now. And yeah, I think that's the one to go for. We can always go through this list instead. Scroll through, you can see there are a lot of radiators here that we can choose from. But I don't, so here you can see I've got a 500 by 1000, 1594. It's about right, but I don't really want a 1 meter radiator in there. However, if I went by 750 by 800, I'm only slightly larger, and I'm slightly larger on the height as well. So I'm going to select this, even though it's a little bit bigger than perhaps we wanted, unless, yeah, I think that works out quite right. So we're going to put that one in, a 750 by 800. We're going to put that one in there, select that, and there you can see it's 5.5% above where we need it to be. So that's adequately heated now, which is great. So that's room number one, and that probably gives you a bit of an idea there about what you then do with the rest of the rooms. And what I would suggest you do is, if you are doing a whole house, and I would just go through and do all of and obviously you've got existing. I would go through and import all the existing ones to begin with, to see what kind of output you're going to get from everything. So I'm doing this, and you can see that actually what's happening here is it's ticking everything off quite nicely. Okay, so there we go. We've got our all our radiators done, and actually we've got a scheduled output of a lovely 9.57 kilowatts, and that's telling me that my system flow temperature needs to be minimum of 43.6 degrees centigrade thanks to the small study. So if I go back to here and I go into my small study, we can see that that is only 0.2% above target. So what we're going to get here, yeah, so if I collapse all of these, what we can see here is that we're given a figure of the output and the percentage difference in output. Now, this is obviously giving us the calculated minimum system flow temperature, which is really helpful because obviously it then gives us an idea of what room is actually setting this flow temperature. And the idea here, at least the way I approach this, is that if I can, when I'm sizing radiators throughout a house, I would like them to have a fairly good even distribution of kind of the percentage by which they are oversized. So if I can, I like to oversize them slightly. Obviously it depends on the space and the practicality of doing so, but I like to have a little bit of an even margin on all of these things. Now what we can see here is that the small study is setting the flow temperature because it has the smallest margin in terms of its output. So what I want to do now is I want to, I think I'm going to increase the size on this one. So what I'm actually going to do is I'm going to replace this one. I'm going to add a new one, and I'm actually going to do a 600 by 500 radiator on a K2, and that will give us a 40% uplift on that. So what you'll see here then is that now it's my main bathroom that is causing me the highest flow temperature. Now, as I can see here, is that I'm way better than my planned 45 degree flow temperature, which is really good. I'm just being a little bit picky here because I'm kind of going, well, I'd like to get it to 40 actually. So I got my 42.3. So what I'm going to do is go back to my main bathroom, and I'm going to have a look in there, and that's a 600 by 600 in the main bathroom. So I'm actually going to, that one actually has a new, that one has a towel radiator that we're going to add in there anyway, because at the moment it has just got a radiator. So I'm just going to do a check. I don't think that's in my database here. No, it's not in there, and it's not down there. So because it's not there in the database, I can add my own radiator. So I'm just going to add my own little radiator, towel, rad. So its height is 1.8 meters and its length is just 450, and the output DT is 380 watts, and contents per litre is 11. And then I'm just going to put towel radiator there as my type and manufacturer specification. So I'm going to add and select that one, and see now we're 40% up on that output. And if we go back up to here, we've reduced this to 42 degrees, and now it's our little ensuite here that is driving this temperature. Personally, I'm really not going to worry about this because I know that now I've got 3 kilowatts scheduled output in excess of this total sizing emitter load. And I know that if I look, every single radiator here, barring my little inner hall, but that's really inconsequential because that's connected to the main hall, everything here is massively over-spec'd. So this really is going to make no difference at all on the overall output of the system. And I reckon that on this, we're probably going to be able to reach a flow temperature of way below 40 degrees centigrade anyway when the system is running. So I'm not going to worry about that anymore, but I'm hoping that that gives you a little bit of an indicator of how you might be able to use this this radiator, you know, sort of the emitter sizing component, and also how you might go about adding you know, radiators and so forth. So I'll just go through that, you know, one more time just in case. We've obviously added a couple of radiators, but if you want to add a radiator, you just click add. It comes in as new. You can search using dimensions if you want to, and the system will bring up radiators from the global database or from your own database, or you can go in here and select manual. So you will have your specifications. These are radiators that you've put in yourself. You will have a database of manufacturer type of radiators in there to select from, or you can go in and add your own radiator here. So all you need to do then, name, model and series, given the height and the length of the radiator, the rated output at delta T 50 from the manufacturer's catalogue, and then your water content. That's really important to get the water content from the manufacturer's specs, because that goes into the system volume calculation later on. So really do try hard to get that data. They should publish it. And then obviously you can say your source is either manufacturer spec or site found if it's an existing one you want to put in. So yeah, I'm hoping that's helpful. Gives you a little bit of a brief overview of how to size your emitters. I will probably end up doing more videos on this to explain some of the fundamentals a little bit more. But in the meantime, if you've got any questions or comments, please leave them down below. Please do like and follow if you're enjoying the content and it is useful to you. And other than that, I will look forward to seeing you in the next video. And yeah, thank you very much for checking in and watching the video. See you again soon. Bye.